All right, next we have example 1, which is to calculate the line integral of the given function f, which equals x plus y plus z over the helix parameterized by cosine t, sine t, t for t between 0 and 2 pi. So essentially we're going to be following this theorem right here, which tells us how to compute it. So if we know that our path is given by r of t, and we know that the range is a to b, then we need to replace every x, y, and z in f with what r says x, y, and z should be. So if we're down here in our helix, x is cosine of t, y is sine of t, and and z equals t. So essentially what we should do here is we have our starting integral, which is, let's do this in black, the integral over the path c. So what I'm doing is they didn't give this the name c, so let's just go ahead and say that this is what our path c is. We've got our function, which is x plus y plus z ds. So we know the range for t is 0 to 2 pi. We know that x is cosine of t, y is sine of t, and z is t. Then we need to multiply by the magnitude of the derivative. Well, we can do this all off to the side. This is usually how I do it. So the derivative, r prime of t, is negative sine t cosine t 1, the magnitude of which, sine squared t plus cosine squared t plus 1 squared is 1. And then, of course, these two is that Pythagorean identity, so that collapses down into 1 plus 1, so square root of 2. So we can take that, and that will go right here, because we're supposed to multiply by the magnitude of the derivative. So this will become a square root of 2 dt. And of course, that's a Calc 1 integral. So you guys can do that. This will then just be, final answer is 2 pi squared square root of 2. That's the answer.